Puma Punku's precise cuts, the machine-aged mystery. At an altitude of 12,800 feet on the stark, desolate Altiplano Plateau of Bolivia, lies a site that defies logic. This is Puma Punku. Most ancient ruins show the gradual decay of time, but Puma Punku looks different. It looks like a complex structure, a temple, a pyramid, a gateway, that was violently shattered, its massive stone components scattered like children's building blocks after an explosion. But the true astonishment is not their placement, it is their perfection. We are told this site was built around 500 to 600 AD by the Tiwanaku civilization. Conventional history states they had no steel, no iron, no mechanized cutting tools, and no wheel. Yet, the scattered stones here, made of volcanic andesite and hard red sandstone, bear tool marks and precision that seem to require all of the above. This is the Puma Punku paradox. Chapter 1, The Scale and the Transport Paradox. Before we examine the cuts, we must grasp the overwhelming scale. The Tiwanaku architects worked with two primary stone types, both presenting immense logistical problems at this extreme altitude. The largest blocks, made of red sandstone, are colossal. The largest intact slab remaining, part of the Plataforma Litica, measures over 25 feet long and is estimated to weigh up to 131 metric tons, the approximate weight of a modern fully loaded main battle tank. These immense blocks were sourced from a quarry located roughly 10 kilometers away. The task of moving a 131-ton mass over the high plain and up a slight incline without the aid of rolling logs, oxen, or wheels, only ropes made of animal hides and sheer human force, is an engineering nightmare often dismissed by modern experts as highly improbable, if not outright impossible. Then there is the smaller yet harder stone, andesite. This volcanic rock is exceptionally difficult to work, ranking near granite in hardness. These blocks were transported from quarries located up to 90 kilometers away on the Copacabana Peninsula, requiring transport across Lake Titicaca itself. The level of organization and logistics required to manage these quarries, the movement of thousands of tons of material, and the highly specialized workforce required to shape it, suggests a societal sophistication that traditional histories of the Tiwanaku often overlook. The effort alone is a monumental mystery. Chapter 2, The Signature, Modular H-blocks and perfect joints. The true stars of Puma Punku are the intricate interlocking pieces, most famously the H-blocks. These are monolithic stones, each carved from a single piece of andesite, shaped like the letter H, and designed to fit together like a massive, self-correcting puzzle. The construction technique utilized here is extraordinary. The blocks fit together with such precision that they form perfectly flush, load-bearing joints without the use of mortar. Archaeologists and stone masons have observed that in many instances, not even a razor blade can be inserted into the seam between two fitted blocks. This is not simply a demonstration of skill, it is a demonstration of standardization and repeatability. Imagine a factory production line. Every H-block and every architectural lintel has complex internal cuts, angles, and negative spaces that perfectly align and interlock with the components next to it, below it, and above it. This suggests the use of fixed templates, standardized measurements, and a rigorous quality control process, concepts we associate with modern, industrialized manufacturing, not ancient stone workers using simple hammers and grit. The uniformity of these components is the strongest argument that the builders possessed knowledge of descriptive geometry and prefabrication on a scale unheard of for the time period. Chapter 3, The Impossible Cuts, Drill Holes and Right Angles. The most compelling proof of an engineering anomaly is found in the microscopic details of the cuts themselves. Look closely at the angles. The stones feature perfect 90-degree exterior corners, which are challenging enough. But they also display perfect 90-degree internal corners. This distinction is critical. Using a stone hammer or chisel, the accepted Tiwanaku tools, to create an internal corner results in a rounded curvature at the apex, as the tool's radius prevents it from achieving a sharp inner point. To achieve a perfectly crisp interior right angle requires a tool with an edge thinner and harder than the rock itself, or more likely, a linear or rotary saw operating at high speed. The flawless nature of these cuts strongly suggests the use of a cutting mechanism unknown to the Tiwanaku era. Furthermore, many blocks contain uniform, perfectly circular drill holes. These holes are often found in symmetrical patterns and feature consistent diameters, around 6 millimeters, and depths, indicating a controlled, high-speed rotary process. Simple hand-powered bow drills, which use stone and abrasive sand, would leave erratic, non-uniform scoring marks and struggle immensely with the hardness of andesite. The uniformity of the Puma Punku drill holes points directly toward the use of a fixed, powered rotary tool, a drill press or its ancient equivalent. The fact that many are blind holes, not penetrating the entire block, further suggests a calculated, mechanical operation. Chapter 4, The Archaeological and Alternative Theories. How do we reconcile these impossible cuts with the supposed lack of technology? The mystery has spawned two primary competing theories. Theory A, the power of persistence and manpower, the mainstream view. Archaeologists maintain that the stones were shaped through relentless percussion and abrasion. The Tiwanaku used hematite or diorite hammerstones, which are harder than andesite, to pound and chip away at the rock. The final polishing and shaping were achieved through an unending process of grinding with abrasive sand, water, and perhaps specialized stone tools rubbed back and forth for months or years. This theory emphasizes the unlimited time available and the immense workforce dedicated to the project. The flaw in this argument, as noted by engineers, is the difficulty in explaining the perfect interior 90-degree angles and the precise, consistent drill holes using this method. Patience alone does not create precision. Theory B, lost technology and the geopolymer hypothesis, the alternative view. This radical theory suggests the blocks were not carved but cast. Proponents, including material scientists like Joseph Davidovits, argue that the Tiwanaku may have possessed an advanced knowledge of geopolymer chemistry, the ability to reliquefy the andesite and sandstone dust and pour it into molds, creating an incredibly hard, durable, yet perfectly shaped stone block. This explains the perfect angles, the lack of tool marks as it's a mold, not a cut, and the precise interlocking shapes. Chemical analysis of some Puma Punku samples has reportedly found organic binders and elements inconsistent with natural quarried rock, lending weight to the artificial stone idea. This hypothesis, if proven, would not only explain Puma Punku but would rewrite the history of chemistry and engineering on Earth. Conclusion. Puma Punku remains the ultimate challenge to our understanding of ancient capability. Is it the crowning achievement of simple tools and human dedication, or a haunting fragment of a lost civilization that wielded a forgotten technology? The ruins, scattered across the cold plateau, hold the secrets of one of history's most profound enigmas.